Hey guys, so in this video, I'm going to show you how to use kinematics graphs to describe motion. So we're going to take a look at how we can look at the shapes of position, velocity, and acceleration versus time graphs just to get a qualitative description of motion, to be able to say what direction something is moving in, whether it's moving with constant speed, speeding up, or slowing down. And if you're given one of the types of graphs, how do we then translate that into the other two? Or if we're given a description of motion, how can we then create the matching graphs? So I'm going to walk you through each graph shape first for position, velocity, and acceleration, and then we'll get into a couple of examples. So if we're looking at a position versus time graph, you kind of have like two main things with these graphs that you want to be looking at. So I want to start off here with an example where we have just a positive constant slope. So with all of these graph types, the two kind of main important things here are going to be the slope and being able to describe the slope. And then it can also come into play too, whether that line is like above or below the x-axis. So let's talk about what that means for a position versus time graph. So one thing to remember here is that any of the points that are above the x-axis, so on the y-axis here, we have all position points. So x here stands for position. It's not our x-axis. Don't get confused by that. But if you're above the x-axis for a position versus time graph, that just means that the object is at a positive position, or usually to the right side of the origin. If you have points that are below the x-axis, like down in this area, you just have an object that its position is to the left, usually the left of the x-axis. That's not like super important for position versus time graphs. Usually what's going to be a little bit more important with these is what is our slope like? And when we're trying to describe the slope, there are two things that we want to focus on. So number one, is our slope positive or negative? Because what the sign of the slope is going to do is that is going to tell you the direction of motion. So if the slope is positive, like what we see here, that means that you are going to have an object that's moving in the positive direction. But if you have a negative slope, like if you have something where the object is going like this, that's a negative slope, and that indicates that the object is moving in the negative direction. So we can tell the direction of motion from the sign of the slope. The other thing that we want to focus on with slope is the slope constant, meaning does the slope look like a straight line, or is our slope increasing, aka getting steeper, or is it decreasing and getting less steep? So in this first example here, the blue line shows a constant positive slope. So that would correlate with a constant positive velocity. So however we describe the slope, that is how we're describing velocity. For our yellow line here, this is still constant because it's a straight line, but it's a negative slope. So here we would see an object that is moving with constant velocity in the negative direction. Another option here that we could see for a position versus time graph would be an object that has increasing speed, it's speeding up. And so if we're going with this idea that if how we describe our slope is how we describe velocity, for something that has an increasing velocity, we're going to see an increasing slope, or a slope that is getting steeper with time. So if you have an object that is moving in the positive direction and speeding up, your graph's going to look like this. So if you're familiar with the idea of tangent lines, if we were to like draw a couple little tangent lines here, and all those do is kind of indicate this slope at like these very specific points in time, our slope starts off maybe even at 0. It's it's not steep there, but then it gets steeper and steeper and steeper over time. So that's how we can kind of see here that this is an increasing slope. So our blue line shows increasing positive velocity. And to show an increasing negative velocity, we want a slope that's getting steeper, but it has a more like downward kind of trajectory. I'm not going to draw over top of that. We're going to kind of go in the opposite direction here. But that would be a negative and increasing slope because, again, you have a slope that starts off, it's not very steep here, but as time goes on, the slope of that tangent line gets more and more vertical is another way we can think of like what it means to be getting steeper. So here you would have increasing but negative velocity. And our last set of options here would be decreasing velocity. And to show decreasing positive velocity, we want a slope that's positive but getting less steep over time. So that is going to look like this. So again, looking at our tangent lines, it starts off steeper, gets a little less steep and a little less steep, and at the end it's almost like a flat horizontal line. So here we have decreasing positive velocity. And to show that as a negative decreasing velocity, our graph shape looks like this. Again, starting off steep, getting less steep, and kind of flattening out over time. So those are kind of all of our options here for position versus time graphs. So let's go ahead and look at velocity versus time graphs and how we can interpret the variety of shapes that you're going to get there. So for velocity versus time graphs, we have to make sure that we're interpreting these a little bit differently, because if we see the same shape on a velocity graph as we do on a position graph, those are going to tell us two different things. So number one, what you want to understand about velocity versus time graphs is that the slope of a velocity versus time graph gives you the acceleration. The slope of the position versus time graph gives you velocity. So let's look at an option here for a velocity versus time graph where the slope is 0, meaning the acceleration is 0. So if we have a nice flat line here, the slope is 0. We want to look at where is this line in terms of like, is it above the x-axis or is it below the x-axis? If it's above the x-axis here, we're up in this like positive velocity region. So here, and let's even like kind of imagine, what if we had a number that went with this, like 4 meters per second? This would be an object that has a positive constant velocity. So it's moving in the positive direction at a constant speed. It is not accelerating. On the other hand, let's look at a velocity that is constant and negative. So we'd be down here below the x-axis for negative velocities. So the difference between this velocity graph and this velocity graph could be simply just the direction of motion. So if this is at -4, both of these objects are moving with the same speed, but this indicates a negative direction of motion, this indicates a positive direction of motion, but neither of these are showing acceleration. All right, so let's consider here a velocity that is increasing. Okay, so again, if we're taking a look at this graph here, we want to think about what's going on with the slope, and also, are we above the x-axis or below the x-axis? If you're in AP Physics 1 or an algebra-based physics course, you're not really going to see curved velocity graphs because that would indicate a changing acceleration, which we don't really get into. But we're going to see velocity graphs that are either horizontal or you have a positive or negative slope of a straight line. So with this graph, we see that it's above the x-axis, indicating that velocity is positive, so it's moving in the positive direction. But this line is also moving away from 0. So here we have a positive and increasing velocity. And we want to be super, super careful and clear about like what are we describing here? Are we describing the position? Are we describing velocity? Are we describing acceleration? So I know that I'm describing the velocity because I'm just really looking at like, what are my y coordinates doing? If we imagine a few points along this line, that's describing the velocity. So my y coordinates are getting more and more positive, so that's positive increasing velocity. If I want to describe the acceleration from this graph, all I can say about the acceleration is that the acceleration is positive and constant And I'm getting that piece of information by describing the slope of my graph. So the slope is going to tell you about acceleration, and that's something that we can use also to kind of like check in and see, is this something that is speeding up or slowing down? Because something that has the same sign for velocity and acceleration is going to be something that's speeding up. So on the other hand, let's look at something that also has increasing velocity, but it's moving in the negative direction. So if we want to talk about, again, something moving in the negative direction, we're looking at something that is going to be a line below the x-axis. So negative increasing velocity looks like this. And don't let it trip you up here. So if we kind of think about some numbers, if we were to put some numbers to these, like -1, -2, -3, -4. The negative sign here only indicates direction. So like -4 meters per second is a faster speed than -1 meter per second, or it's a faster velocity. So don't let the sign trip you up. It's just an indication of direction. So if I wanted to describe here what is going on with velocity, I would say that this is a velocity that is negative and increasing. But if I want to describe the acceleration from this graph, I'm looking at the slope. So my slope here is negative and constant. So that is what's going on with acceleration. All right, so again, we're being super clear. Are we describing velocity? Are we describing acceleration? Acceleration comes from slope. So our last two graphs here, we're going to look at now decreasing velocities. So if I have a positive and decreasing velocity, I'm above the x-axis, but I have a line that's heading toward 0. My y-coordinates are getting smaller and smaller and smaller as time goes on. So I have a positive decreasing velocity. But if I'm describing acceleration, I'm looking at the slope. So here I have a negative constant acceleration. So I'm using a little bit different abbreviations on my different graphs here. But then if I want a negative and decreasing velocity, I'm here below the x-axis, and the line on my graph is heading toward 0. So I have a negative decreasing velocity, and when I'm describing my slope, I'm describing acceleration. So I have a positive constant acceleration, okay? And so this isn't necessarily like directly related to graphs, but I'll mention it anyway. So notice here with our graphs where we have increasing velocity, the velocity and acceleration have the same sign for increasing velocity. So something that's speeding up, velocity and acceleration, same sign. But if you have something that's slowing down, the velocity and acceleration have an opposite sign. So that's something that we see illustrated here on our graphs. All right, so lastly, we're going to look at here just some options that we have for acceleration versus time. And for these, you kind of get like 3 options for the most part. Again, like if you're in an algebra-based physics course, like AP Physics 1, we're not looking at changing accelerations. So if you have an acceleration graph where that line lies directly on the x-axis, you have no acceleration, you have an object that's moving with constant velocity, which could also mean that it's at rest. You could have a positive acceleration, positive and constant, or you could have a negative constant acceleration. If you have an acceleration graph alone with like no other description of motion, no other graphs to match it up with, all you can say is the sign of acceleration. You cannot necessarily tell if the object is speeding up or slowing down. Based on the acceleration graph alone, you'd have to have some information about the direction of velocity. So let's get into some examples here where we're using a description of motion to help us draw these matching kinematics graphs. So first we have an object that starts at a negative position and moves in the positive direction at increasing speed. So knowing that we have a negative position to start means that on our position versus time graph, we have a negative y-intercept. If we're moving in the positive direction, that means our position versus time graph has a positive slope. And the fact that we have increasing speed means that we have a slope that is getting steeper over time. So our position versus time graph will look like this, Okay, we have a positive increasing slope, but we have a negative y-intercept to indicate that negative initial position. On our velocity versus time graph, we want to indicate now just positive increasing velocity. The fact that we start at a negative position has no bearing on what our velocity versus time graph looks like. And it doesn't specifically state this, but let's imagine here that our initial velocity is 0. It's starting at rest. So if we want a positive increasing velocity, we need to be above the x-axis and moving away from 0. And to translate that to our acceleration versus time graph, we're just really looking at the slope of our velocity versus time graph. So if we have a positive constant slope here, we have a positive constant acceleration. All right, so those three graphs, they all match up with each other to describe an object that starts at a negative position but moves in the positive direction with increasing speed. All right, example number 2. We have an object starting at the origin and moving in a negative direction with decreasing speed. So starting at the origin just gives us a y-intercept on our position versus time graph. And if we're moving in the negative direction, we have a negative slope on our position versus time graph and a slope that is decreasing or kind of like flattening out over time. So negative and decreasing slope on our position versus time graph looks like this. On our velocity graph, we have negative decreasing velocity. So we're down here below the x-axis and we want a line that's going to be heading towards 0. So a negative decreasing velocity looks like that. And if we describe our slope here, we could describe that as positive and constant again to get our positive constant acceleration graph. And last example, we have a positive position to start, and we're moving to the right, which we'll take to be the positive direction, with a constant speed. So starting at a positive position means our y-intercept on position versus time is positive. Moving to the right, we have a positive slope. Constant speed means we have a constant slope. So we have a constant positive velocity. And if the velocity is constant, our acceleration is 0. All right, guys, so I hope that helped a little bit. I know that it can be confusing with all of these different graph shapes and understanding what the different features of the different graphs mean, but essentially we want to know that with our position versus time graphs, our slope gives us velocity. So however we describe the slope of our position versus time graph, that is directly describing what the velocity is like. On our velocity versus time graph, some things to know is that we want to pay attention to whether we're above or below the x-axis for the direction of motion. Above the x-axis means we have positive velocities, therefore moving in the positive direction. Below the x-axis, we have negative velocities, therefore moving in the negative direction. And on our acceleration versus time graph, we basically are just either going to have a flat line above the x-axis for positive acceleration, a flat line at the x-axis for no acceleration, or a flat line below the x-axis. But that information is going to come directly from the slope of our velocity versus time graph. If you want to check out more videos like this one geared toward AP Physics 1 students or other algebra-based physics courses, like, subscribe, and follow me. You'll get updates for more videos just like this one geared toward AP Physics 1.